Okay. All right, so 9-2. Multiplying and dividing rational expressions. Okay, so 9-1 we did adding and subtracting. So now we're doing multiplying and dividing, okay, of our rational expressions. Okay, so let's start with the easy stuff. What did you learn way back in, what was it, 4th grade? I don't remember what grade level you guys learned fractions. I should find that out. Example number 1. Whoa, 1. Okay, how do you multiply fractions? Straight across? So, like, this is going to equal 20/30ths. And then we can say, oh, well, that's actually reduces to 2/3. Okay, that was pretty easy. Did anybody do that differently? How would you do that, Emily? Oh. So like we got a 5 on the top and we got a 5 on the bottom, so they cancel. And then 4/6 can be reduced by 2. So we have 2 and 3, so that's just 2/3. Does that one make sense? You remember doing the reducing stuff and canceling stuff out? Okay. Both ways work. It's kind of up to you which one you want to go with. Okay, so that's exactly what we're going to do today, but now we're going to do it with x's. Alex and Connor, put that phone away for me, please. Connor, phone away. There you go. All right, here's example 2. All right, so what I'm going to do is I'm going to step this out so we can follow our little sequential steps. So when you're taking the test, you know exactly what to do. Ready? Anybody know what the first step is? Not yet? Okay, right before that, what I want to do is I want to write it in a form that I can cancel stuff out. Okay, right now, these are written in standard form. Okay, and you can't just say, oh, well, the x's are going to cancel right here. That's illegal maneuvering. Don't do it. Okay, you cannot cancel until everything is multiplied together. So what we have to do first is write everything in factored form. Okay, so step 1 is factor. Factor, factor, factor. Okay, so factor the top and the bottoms. Okay, factor the tops and the bottoms. Okay, so let's do that. 3x squared, can I factor that? No, that's a monomial. Can't factor one term. Okay, what about the bottom of the left one? What two numbers multiply to -8 and add to -2? -4, +2, so x minus 4 and x plus 2. Okay, what about the top right one? What could I do to factor that one? Anybody notice there's a greatest common factor there? Okay, so let's start by pulling out a 2. Okay, and then I would have x squared minus 6x minus, nope, sorry, just kidding. I was just seeing if you were paying attention. Good job. Okay, and then could I factor that further? Okay, what two numbers multiply to 10, -10 and add to -3? -5, +2. I'm just going to erase this and write -5 and +2. Okay, what about the bottom on the left, or excuse me, right side, bottom right?
Yeah, that's right.
For x, so if I pull the 2 out on this, I would have x squared minus 3x minus 10.
Wouldn't it be, I mean, it's just 2 x minus 5 and x plus 2, would it be x plus 5 and x minus 2?
Oh, no, it would be minus because you need to get a negative 3. So negative 5 plus 2 is negative 3.
So you wouldn't,
right? Okay. What is the bottom one factor to? Same thing, right? Did you notice that right away? Probably did. Okay. So once I factor, what's my step 2? Cancel, yeah, see what cancel. So now step 2, cancel. Okay, so what things can I cancel? X plus 2. Now, I see 3 x plus 2's. Can I cancel all of them?
No.
No, right? I can only do 1 on the top and 1 on the bottom. It's got to be on the top and the bottom to cancel. What else can we cancel? X minus 5's, anything else? No. Okay, what's my step 3? What do I do? Okay, so specifically, how do I solve? Be more descriptive. Multiply straight across. Perfect. So multiply straight across. Okay, so what would I have on the top if I multiply straight across? 6x squared, and what would be left on the bottom? X minus 4 and x plus 2. Okay, so that is my reduced expression. The last thing I have to do is what are the values that x cannot be? Okay, just like we did that with adding and subtracting, what values can x not be? What'd you say? 5. Okay, good. So I hear 5, negative 2. Did anybody say 4? Okay, good. I didn't hear it, but I assumed. Okay, so do notice, okay, I did have to include the 5, the value that did cancel. That is part of the original. It's a restriction. One more? Sure, yeah, one more. Sounds good. Good idea, Miss Nolte. Okay. Ooh, let's do this one. Number 2. Okay, so for number 2, what do I start with? What do I do first? Factor, okay? So I factor first. Can I factor x squared minus 9? Perfect binomial, right? So what does it factor into? X minus 3 and x plus 3. By the way, you're going to see lots of perfect binomials in this section. I like to throw those in there. Okay, what about the bottom of the left? What two numbers multiply to negative 24, add to negative 5? Yeah.
Negative 8 and positive 3.
There you go, negative 8 and positive 3. Okay, what about the top right? It looks linear, I like it. Okay, what about the bottom right? Pull a 2x. So if I pull a 2x, what's left?
X minus 9.
X minus. Ooh, is it?
No, sorry, just saying.
Ooh, yeah, if it was x squared, then it would be. Which I could see how you could easily make that mistake because you saw the x squared previously. Okay, so what cancels? Ooh, good. So I see an x minus 8 canceling. You see how you can cancel across like that? Top and bottoms. Okay, what else do you see? X plus 3's. Anything else? Looks good to me. So what's going to be left on top? X minus 3. And on the bottom? 2x and x minus 9. Okay. Now, would anybody be like, well, that's actually the same as x minus 3 over 2x squared minus 18x. Anybody feel like they want to do that? No, that's
It's a
super.
good way to look smart.
Okay, yeah, it's extra work, you're right. Would it be a wrong answer? No, okay? I mean, this one is completely the same as this one, it just is written in a different form, okay? But I would leave it here because then, you know, you don't make that mistake. Okay, what are my restrictions?
8, -3, 9.
Can't be 8? What'd you say? Oh, -3, 9, 0. Wow, that's a lot. The 0 comes from the x right here. Just by itself. Okay, so what do you guys think? Good with multiplying?
Yeah.
Want another example multiplying? Feeling good about multiplying? Okay, so let's do dividing.
Ribs. Oh, is that the reciprocal thing?
Okay, so let's talk about way back in 4th grade. And they said, what's 2/3 divided by 4/5? What happened?
Reciprocal.
Okay, now you're saying reciprocal. What do you mean? What are we doing?
Flip the second one.
Flipping which one?
Second one.
The second one. And when we flip it, then what happens? Then we multiply, right? We change it, so it's the same as multiplying by the reciprocal. Okay, and then you can do your little reducing thing. So at this point, it just becomes exactly the same as what we were just doing, right? So 5/6.
Right.
Okay, so basically dividing is just one additional step. What's my one additional step? Flip it. Okay, so maybe on your dividing notes, you can say same steps or process as multiplying, but multiply by the reciprocal of the second first. Okay, or write whatever in your notes that's going to make sense when you're taking the test. So maybe multiply
So
by the reciprocal.
Teacher ever explains to them why flipping them actually works.
That's a good question. Can I pause? Can I answer that at a different time?
Sure.
Okay. I want to see if I can come up with a good answer before trying to stumble through it. So I will answer that later, maybe at the end of class today. Okay, so let's do this example. This is example 3, 4, 5, 7. Sure, 3. Sounds good enough to me. All right, so what do I do first? Flip them, okay? The very first thing I do before I do anything else, just flip it. Okay, I multiply by the reciprocal. Such an easy step, and I can't believe how many people just forget to do it. Okay, now what do I do? Factor. I like my first fraction. That one is factored for me. So I'm just going to rewrite it. Okay, what about the right one? What two numbers multiply to -2 and add a +1? 2, +2, and -1, good. Okay, what about bottom? What two numbers multiply to 14 and add to 9? 7 and 2. X plus 7, x plus 2. Okay, now what cancels? Ooh, good. Everybody said one of the x plus 7. So see how this is two of them? So the way I'm going to do this, and it's kind of up to you how you want to, but I think this works. The one on the bottom cancels out, and then we don't have two of them anymore. That work? Okay. What else?
X plus 2.
The x plus 2's go away. Anything else? Looks good to me. So on the top I have x plus 7. I have x minus 1. And on the bottom I have x squared. Okay. Restrictions. What are the values that x cannot be?
-7, 2,
-7, -2, 0. There's one more.
1.
Okay. The other one is 1.
So the ones on the top still count.
Okay. Yeah, because they were originally on the bottom. Okay, so this 1, remember, was flipped upside down the other way. Okay, at some point there was a 0 in the denominator. Okay, so this one that flips, and that only works on the second fraction. We're not going to look here. Okay, so if this was like, I don't know, x plus 5 or something, that would not be a restriction. It's only of the second fraction, the one we flipped. Okay. How do we feel about dividing? More examples? Phil and Golden? You guys like